Ever wondered how vast the universe might be? Let's take a moment to marvel at the sheer magnitude of our cosmos. To truly grasp its size, we have to step outside our earthly confines and journey into the realm of the mind-bogglingly immense. Imagine, if you will, a grain of sand. Tiny, isn't it? Now consider this. If our planet Earth was the size of that grain of sand, the sun would be roughly the size of a large grapefruit. In this scale, the distance between our sand grain Earth and grapefruit sun would be about 10 feet. Scaled up, this represents the 93 million miles that separate us from the sun in reality. But let's not stop there. If we continue on this cosmic journey, our Milky Way galaxy, on the sand grain scale, would be about the size of North America. And that's just one galaxy, our own modest neighborhood in the cosmic expanse. Now, speaking of the universe, we're dealing with something far larger. The observable universe, the part we can see with our current technology, is estimated to be about 93 billion light-years in diameter. A light-year, for those who might not know, is the distance light travels in a year, which is roughly 6 trillion miles. Multiply that by 93 billion, and you're left with a number so enormous it's nearly impossible to comprehend. And remember, that's just the observable universe. The parts we can't see, the parts beyond our cosmic horizon, could stretch on for infinity. We're like ants trying to comprehend the size of an entire continent or even the entire planet. So next time you look up at the night sky, remember you're seeing just a tiny fraction of the universe. We're part of something much, much larger, a cosmic tapestry woven with galaxies, stars, and mysteries yet to be unraveled. The universe is a vast, beautiful expanse, and we're just beginning to explore its unfathomable depths. Scene script. Have you ever thought about how old the universe might be? Well, sit tight, because we're about to dive into a cosmic journey through time itself. Scientists estimate that our universe is around 13.8 billion years old. Now, that's a number so large, it's nearly impossible to wrap your head around. But how did they come to this mind-boggling conclusion? The key lies in something known as the cosmic microwave background radiation, or CMB for short. This faint glow left over from the Big Bang provides a snapshot of the universe when it was just 380,000 years old. By studying the CMB, scientists are able to look back in time and measure the age of the universe. Now you might be wondering, how does this work? Well, the universe has been expanding ever since the Big Bang, and as it expands, the light from the CMB gets stretched or redshifted into longer and longer wavelengths. By measuring this redshift, scientists can calculate how long it's been since the light was first emitted, and voila, we get our estimated age of the universe. But it's not just about the numbers. The age of the universe holds profound implications for our understanding of life, existence, and the grand cosmic drama in which we're all players. It tells us about the life cycles of stars, the formation of galaxies, and the mysterious dark matter and dark energy that make up the vast majority of the universe. It's a strange and wonderful thought, isn't it? That everything we see, from the smallest grain of sand to the largest galaxy, is part of a cosmic story that has been unfolding for nearly 14 billion years. It's a story that's far from over, with new chapters being written every second in the form of exploding stars, colliding galaxies, and perhaps even the birth of new universes. Imagine that the universe has been around for almost 14 billion years, and it's still full of mysteries waiting to be discovered. So keep looking up, keep wondering, and keep exploring, because who knows what fascinating secrets the universe still has in store for us. Did you know that the universe is expanding? A statement that may sound strange, but it's true. The universe, in all its vastness and magnificence, is constantly growing. But how does this happen? Let's delve into this fascinating aspect of our cosmos. When we talk about the expansion of the universe, it's not just about galaxies moving away from each other. It's more complex and intriguing than that. It's the very fabric of space itself that is expanding. Imagine a loaf of raisin bread dough rising in the oven. As the dough expands, the raisins, which represent galaxies, move farther apart from each other. But it's not the raisins moving on their own, it's the dough, or space, that's expanding. Now you might be thinking, what's causing this expansion? The answer lies in a mysterious entity known as dark energy. Despite its ominous name, dark energy isn't something out of a science fiction novel. It's a form of energy that permeates all of space and is believed to be the driving force behind the universe's expansion. Dark energy is thought to make up approximately 70% of the universe, yet, despite its dominance, it remains one of the greatest enigmas in modern science. It was only in the late 90s that scientists discovered its existence, and we are still learning about its properties and influence on the cosmos. The expansion of the universe, propelled by dark energy, has profound implications. It influences the formation of galaxies, the distribution of cosmic microwave background radiation, and even the future fate of our universe. However, the most mind-boggling fact is that this expansion is accelerating. The universe is not just growing, but it's growing faster and faster with each passing moment. So as you sit here watching this video, the universe is getting bigger and bigger. It's a humbling thought, isn't it? Each second the cosmos stretches a little more, the galaxies drift a little further apart, and we find ourselves in an ever-growing, ever-mysterious universe. Can you guess how many galaxies there are in the universe? That's a question that has left astronomers scratching their heads for years. The truth is, it's a number so vast it's almost impossible to comprehend. But we do have a rough estimate, and it's staggering. Scientists believe that there are between 100 billion to 200 billion galaxies in the observable universe. Yes, you heard that right. That's billion with a B. Just try to imagine that for a moment. Each one of these galaxies is a vast spinning disk of stars, dust, and dark matter. And each one is home to billions, possibly trillions of stars. Now, galaxies come in all shapes and sizes. Some are spiral-shaped, like our own Milky Way, with arms of stars and dust spiraling out from a central bulge. Others are elliptical, their stars distributed more evenly throughout. And then there are the irregular galaxies, the mavericks of the cosmos with no definite shape. But galaxies don't just float around in space by their lonesome. No, they like to hang out together in groups. These groups are known as clusters. A cluster can consist of a few dozen to a few thousand galaxies. But it doesn't stop there. Clusters themselves can group together, forming what we call superclusters. Just to give you an idea of the scale we're dealing with here, our own local group, which includes the Milky Way and Andromeda among others, is part of the Virgo supercluster. This supercluster contains at least 100 galaxy groups and clusters, spanning a mind-boggling 110 million light years. So remember, each one of those twinkling lights you see in the sky could be an entire galaxy filled with billions of stars. It's a humbling thought, isn't it? But it's also an exciting one because it means that the universe is a place of infinite possibilities, just waiting to be explored. Ever wondered what the future holds for our universe? We all have, haven't we? So let's dive into some of the most popular theories that scientists have proposed. First up, we have the Big Freeze. This theory suggests that as the universe continues to expand, it will eventually cool down. Now, don't go picturing a cosmic winter wonderland. What we're talking about here is the heat death of the universe. Over trillions of years, stars will burn out, galaxies will drift apart, and all matter will decay into radiation. It's a rather chilling thought, isn't it? Next, we have the Big Crunch. This is the opposite of the Big Freeze. Rather than keep expanding, the universe might actually start to contract. Imagine all the galaxies, stars, and planets reversing their paths, rushing back towards a central point. Everything would become denser and hotter until finally, we're back to where it all started. A singularity, a point of infinite density. A rebirth of the universe could potentially follow in a cycle known as the Big Bounce. Lastly, there's the Big Rip. This theory is a bit more dramatic. It suggests that the expansion of the universe isn't just continuing, it's accelerating. And not just a little bit, but at such a rate that eventually gravity won't be able to hold galaxies, solar systems, or even atoms together. Everything would be torn apart. Now, these theories might sound a little scary, but it's important to remember that they're just theories. We don't know for sure what the future holds for our universe. What we do know, however, is that it's filled with endless mysteries waiting to be unraveled and infinite wonders waiting to be discovered. So let's keep looking up, keep exploring, and keep asking questions. Because no matter what the future holds, the universe remains a fascinating and mysterious place, filled with infinite wonders for us to discover.